So here's the notes for the 5.1 section. And I'll post these notes online, the ones I'm going over, but I'm skipping a bunch of the stuff, the notes I am posting online. This is from a previous section, and so we're not teaching half this stuff anymore. So if you look at the notes, we're going to start on the second page, something called the horizontal line test. So what the horizontal line test does is allows us to see if a function is called one-to-one. It doesn't really necessarily matter what this means. But what it does is tests if a function is 1-to-1. It's going to really what the horizontal line test does. So say if we have a function, and here's its graph. We'll do two examples. So say if here's one graph and here's another one. Okay, so with the horizontal line test, what it means is we draw these horizontal lines, sort of similar to the vertical line test. And we can only touch the graph, if it passes, it only touches the graph in one spot. So say on this graph over here, I'll call this graph number 1, it touches the graph here, it touches the graph here, it touches the graph here. So since we drew a horizontal line and it touches the graph in more than one spot, this one fails the horizontal line test. And if you fail the horizontal line test, that means the graph is not one-to-one. So not one-to-one. See with this example over here, wherever we draw horizontal lines, it only touches the graph here once. If we draw a horizontal line right here, it only touches the graph once. If we draw another horizontal line, only touches the graph once. And that happens for every single horizontal line. We're never going to touch the graph in more than one spot. You draw one up here, again, only touch it in one spot. So just call this graph number 2. So graph number 2 passes the horizontal line test. And since it passes the test, we say it is one-to-one. So as far as the horizontal line test, this is really all you need to know. But this idea of one-to-one, again, so one-to-one means isn't really too important. All you need to know is if you pass the horizontal line test, like in this situation, you are one-to-one. And if you don't pass the horizontal line test, so if you fail it, you're not going to be one-to-one. And the reason why this horizontal line test is important is for something what we're going to do is called the inverse of a function. So let's first just talk about what the inverse means. So we have we've been dealing with things like f of x equals, let's just say x plus 3. So what an inverse does, and we always plug in numbers here and we get numbers out. So for this example, say if we plug in the number 0, we get 0 plus 3, which is 3. Say if we plug in the number 4, you plug in 4 in here, you're going to get 4 plus 3, which is 7. So this is, f, you take 0 and you give it, it turns into 3. With f, you plug in 4, it's going to turn into 7. So what the inverse does is it works the other way around. So if we have the inverse function, say for this one in particular, and we denote it by this little symbol f with a -1 of x. So this is going to work opposite. So if we have the inverse function, we're going to learn how to find it first. We're not necessarily sure what it is yet, but it's going to work backwards. So if we find the inverse function and if we do everything correctly, if we plug in 3, we'll get 0. And if we plug in 7, we're going to get 4. So what the inverse function does is it works backwards. So say if you plug in 0, you get 3. Well, with the inverse function, if you plug in 3, you're going to get 0. So you get what you should put in to get the answer. So again, so say if f is equal to 7, if you plug 7 into the inverse, that's going to give you 4. It's going to give you what you need to put inside the original function to get that number. So sort of just in general, if you have f of x is equal to y, then this means that f inverse of y is going to be x. So whatever number you plug in to get this number y, the f inverse tells you, well, if you get this number, this is the number that you need to plug in. So this is sort of the relation between the two. And the only time we can find an inverse only time we can find an inverse, meaning the only time that this, so there's some times where we can't find this f inverse. So in this situation, we'll see that we can, but there's a lot of times where we can't find a function. So say if we know f of 0 is 3, f of 4 is 7, we can't find a function that tells us this information. So this function may not exist, but we can. So the only time we can find an inverse is when our function, so when f of x is 1 to 1. Or another way to say this, or passes the horizontal line test. So if our function passes the horizontal line test, then we're going to be able to find the inverse. But if it doesn't pass, then we're not going to find the inverse. As far as all these examples are going to go, so there's a lot of the homework problems. See the homework numbers that I'm referring to. So I think it's like problem let's see. Nope. So from problem number 8 to about problem number, I think 12, it asks you if a function is 1 to 1 and then find its inverse. All the functions that we're going to be dealing with are going to be 1 to 1. So we don't really need to worry about that too much. So the only time this is really helpful, the horizontal line test, is when you have the graph. Most of the times it's really hard to find the graph. So as far as all these examples go in the homework, they're always going to be 1 to 1. And so now we'll learn how to do the techniques to find the inverse. But in general, we can only find the inverse if the function is 1 to 1, or if it passes the horizontal line test. So let's do a simple example, this one up here. So we have f of x is equal to x plus 3. And we want to find f inverse of x. So no matter what the problem is, what this looks like, the technique is always going to be the same. Sometimes it's easy to find, sometimes it isn't. So what we do to find f inverse of x, so there's a series of steps. The first is we're going to replace all f of x's with y's. Meaning, so if we see an f of x, we're just going to write a y. We'll do all these steps in a second. The second step is going to be to replace the x's and y's, which basically just means if we see an x, we write a y, and if we see a y, we write an x. But so we'll illustrate that in a second. And the third is going to be then solve for y. So these 3 steps are going to be the same to find the inverse for any type of function that we're dealing with. So for this one, f of x is equal to x plus 3. We look over here. The first step is replace all the f of x's with y's. Okay, so here's an f of x. Let's put a y here. So we're going to have y is equal to x plus 3. The second step is replace the x's and the y's. So if we see a y, we're going to put an x. Here's a y. Now we're going to write an x. Here's an x. Now we're going to write a y. Okay, plus 3. And just everything else is the same. So if there's a plus 3, we're still going to write the plus 3. And the third one is solve for y, meaning just get y on one side of the equal sign and everything else on the other side of the equal sign. Well, the only thing attached to this y is this plus 3, so all we need to do is subtract this 3 over. So we subtract the 3, subtract the 3, and we're going to get y is equal to x minus 3. And once you're done with this step, solve for y, this y is going to be the f inverse of x. So this piece right here, x minus 3, that is your f inverse of x. So what this tells us is f inverse of x is equal to x minus 3. When f of x is equal to this. So if you look up here, we saw f of 0 is 3. And that means we needed to have f inverse of 3 being 0. If you plug in 3 to this function down here, you do get 0. You get 3 minus 3, which is 0. Up here, we had f of 4 was 7. You plug in 4, you get 7. Okay, so that means if we took our f inverse function, we plugged in 7, we needed to get 4. But if you plug 7 into here, you just get 7 minus 3, which is 4. So you see this function, this is the same thing. We have our, f of x is x plus 3, f of x is x plus 3, and we found our f inverse of x was this, and it does work out. So if we plug in 3, we get 0. You plug in 3 here, you get 0. You plug in 7, you get 4. Here, you plug in 7, you get 4. But the main, I guess, idea for finding the inverse is these 3 steps. So these 3 steps work for anything. And so we'll do a couple more examples that just increase in difficulty. But still, it's these same 3 steps over and over. Let's do the next example. So the next one we want to do is, let's say we have f of x is equal to 3 over x plus 1. And again, just let's find f inverse of x. So we're going to do the same steps. The first step was, if you see an f of x, you're going to plug in a y. So here's f of x. We're going to rewrite f of x with y. So y is equal to 3 over x plus 1. And if you look back, step number 2 was if you see you replace all the x's and y's. So if you see a y, you write an x. And if you see an x, you write a y. So here we see a y, we're going to put an x here. 3. And here we see an x, we're going to put a y. So y plus 1. Okay, that was the second step. Now the third step is to solve for y. So, we need to get y on one side equals and then just everything else on the other side. So there's a couple of things we could do here. The first thing is well, we have y on the bottom over here. And it's always nicest to get rid of all the fractions. That's always one step we can do. So in order to do that, we can just multiply both sides by this y plus 1. So we can multiply y plus 1 on the right-hand side, but we can also do the same thing on the other side. So we're going to multiply y plus 1 on this side. If we multiply, let's just rewrite this, x times y plus 1. So notice nothing changed here. We just multiplied y plus 1 on both sides. And we did that because if we multiply y plus 1 on the right, it's going to cancel. So you have a y plus 1 up here and a y plus 1 up here. So those two cancel and you're just going to have a 3 on the right-hand side. Okay. So now we just turn this equation into this. We have x times y plus 1. Here's x times y plus 1. And then we multiply y plus 1 on the right. Those cancel and we just have a 3. So now what we need to do is, in order to solve for y, is to... there's a couple things we could do here. Let's do this way. So we can just take this x and we can divide it over to the right. So the whole goal is to get y alone on one side. And right now we have this y plus 1 times x. So we could just divide the x on the left, divide the x on the right. The x's cancel on the left, so now you just have a y plus 1 on the left. And that's going to equal 3 over x. So now we're almost done solving for y. All we have to do is subtract this 1 over. So subtract the 1, subtract the 1. So it cancels on the left, and you're going to get y is equal to 3 over x minus 1. And again, so once you've, just like before, once you ended up doing the step where you solve for y, this is your f inverse. So our f inverse of x is equal to this, 3 over x minus 1. So let's show it has that same property where, you say if we plugged in numbers into f of x. So say if we plugged in f of 2, we're going to get 3 over 2 plus 1, which equals 3 over 3, which equals 1. So that means if we plug in 1 inside of f inverse, we need to get the number 2. So if we plug f inverse, we plug 1 inside of this, we're going to get 3 over 1 minus 1. So this 3 over 1, that's just 3. So we have 3 minus 1, which is equal to 2. So it does work. So we plug in 2 for f, we get 1. That means if we plug in 1 for f inverse, we need to get 2. Here we plug 1 in for f inverse, we also get 2. So that same property still works. So that's just a quick way you could check to make sure you got the right answer. And so we did that, it works. And we'll talk about another way how to check your work too. But just for like a quick little check, this usually is good enough. So anyway, we do the work for this one and we get f inverse is going to be 3 over x minus 1. Okay, let's do another example. It's a little bit more tricky than this one. So how about, say we have f of x is equal to x minus 1 over 2x plus 4. Okay, so still we have the same 3 steps. First step is if we have an f of x, we write a y. Okay, so here's an f of x, let's write a y. We have y is equal to x minus 1 over 2x plus 4. Okay, so that's the first step. Second step, if you see a y, you put an x, and if you see an x, you put a y. Here's a y, we're going to put an x. Equals, here's an x, we'll put a y minus 1. Then we have a 2. Here's another x, we're going to put a y there. And then plus 4. So again, just all we did is if we see an x, we put a y, and if we see a y, we put an x. Here's a y, we turn that into an x. Here's an x, we turn that into a y, and here's another x, we turn that into a y. And now, just like before, we need to solve for y. So get y on one side, everything else on the other side. So just like before, the first step we want to do is to get rid of the fractions. So we want to multiply both sides by the 2y plus 4. So let's do that. Multiply everything by 2y plus 4. So if we multiply it to the left, we're just going to get x times 2y plus 4. And if we do it to the right, well, it's just going to cancel. You have 2y plus 4, 2y plus 4, they go away, and you just have y minus 1. Now in the previous problem, the way we decided to continue is we had this x here, and we just divided x onto both sides. For these type of problems, it's not going to necessarily work. What we want to do is take this x and distribute it. So we want to distribute the x through the set of parentheses, and we're going to get 2yx, just from multiplying the x to right here, and then x times 4, so plus 4x. And then it's just equal to y minus 1. And remember, so what we're trying to do here is solve for y. So get y on one side, everything else on the other side. So what we want to do here is let's get the y's on the same side. So we'll move this y over to the left, subtract the y, and also let's move this 4x over to the right. So subtract the 4x, subtract the 4x. So we're going to have 2yx minus y. These 4x's cancel. These y's cancel, and then you're going to have minus 1 minus 4x. Okay, so now we're almost done solving for y. So what we can do next is, so we see that on the left-hand side, there's a y in this term and a y in this term. So what we can do is factor out the y. Take out the y. And if we do that, so from this piece, if we take a y out from both of these, we're going to have a 2x from this one, and then just a minus 1 from the second one. So again, all we did here is just factor out a y. So if we multiply this y back through, we would need to get this piece. And we do get that. So y times 2x, that's 2xy. Y times minus 1, that's minus y. So when we factor out the y on the left-hand side, we just get this. On the right-hand side, we just still have minus 1 minus 4x. Okay, and then the last thing to do to get y alone is, well, it's being multiplied by this piece, the 2x minus 1. So let's just divide the 2x minus 1 into both sides. So it cancels on the left, we just get y. And on the right, we're going to have minus 1 minus 4x all over 2x minus 1. And again, once you do this step where you get you solve for the y after replacing the x's and the y's, this is going to be your f inverse. So our f inverse of x is equal to minus 1 minus 4x all over 2x minus 1. And again, as a quick check, we can do that same little thing where we can just pick a number to plug in for f. So let's find f of, what's going to be fractions involved, whatever. Let's do f of 1 will be easy. So let's just see what f of 1 equals. You plug in 1 here, you're going to get 1 minus 1 all over 2 plus 4, which is a 0 over 6, which is equal to 0. So we plug in 1, we get 0. So that means for f inverse of x, if we plug in 0, we're going to need to get 1. So if we plug in 0 into f inverse, we're going to get minus 1 minus 4 times 0 all over 2 times 0 minus 1. Okay, so here's minus 1 minus 4 times 0. Well, 4 times 0 is a 0, so the top is just going to be minus 1. And the bottom, again here, 2 times 0, that just goes away, so the bottom is just minus 1. And minus 1 over minus 1, that equals positive 1. So we do get the right thing. See, for f, you plug in 1, you get 0. And for f inverse, you plug in 0, you get 1. It's the opposite. So f inverse is going to take this number and turn it into that number. So it takes 0 and then turns it into 1, which is the inside number. So this is, again, just a quick way to make sure we didn't make any mistakes. So this down here, this ends up being our f inverse. Okay, so the last type of problem that we're going to need to find the inverse of is going to be this. So we're going to have f of x is equal to the cube root of 3x. So let's start with this. So just same first step. If you see an f of x, you turn it into a y. So here's our f of x. We're going to write that as a y equals cube root of 3x. And the next thing we need to do is replace the x's and the y's. So here's a y. We're going to make that an x. Cube root 3. Here's an x. We're going to make that into a y. And so now we need to solve for y. So we get y on one side, everything else on the other side. And whenever you're solving equations with these type, cube roots or just any type of root in general, it's helpful. So this is something that you should have learned in a previous math class, where if you have something like the nth root of x, another way we can write that is just x to the 1 over n power. And it's usually always more helpful to write this symbol as this instead. So instead of writing an nth root, you want to write x to the 1 over n. And so when we solve for y, that's going to be the first step, is to use this property over here. So we're going to have x is equal to, so using this, the n here is a 3, and the x, that's a 3y, the inside piece. So whenever you have the nth root of x, just whatever the inside piece is, it goes right here. And if you have an n, you're going to do 1 over n. So here's our inside piece, 3y. And that's our n, 3. So we're going to put a 1 over 3. So this just translates into that, 3y to the 1 over 3. And so if we want to solve for y here, well, the first thing I'm going to do is take care of this power. So in order to cancel out the power on the right-hand side, we can just take both sides to the third power. So we're going to do the third power on the left and the third power on the right. So if we take the third power to the left, we just get x to the 3. But if we do the third power on the right, this 3 and the 1 over 3 cancel. So we're just going to be left with a 3y. And why that happens is there's another property that you should have learned in previous math class, where if you have x to some number a, and you raise that whole thing to a number b, this ends up equaling x to the a times b. And that's what we have here. So we have 3y to the 1/3, all that being raised to the 3. So what this ends up equaling is 3y to the 1/3. Again, so 3y to the 1/3, all raised to the 3. So this is going to be 3y to the 1/3 times 3. And then this 1/3 and 3 cancel out. Since 3 divided by 3 is just 1, so this is just going to be 3y. And that's what we have down here. So this right-hand side just turns into 3y, and the left just turns into x to the 3. And again, we want to solve for y, so the last thing to do is just divide 3 to the other side. So we're going to get y is equal to x to the 3 divided by 3. Okay, and again, that was our f. We found what the y equals after switching the x's and the y's around. And whatever this y ends up being, that's going to be our f inverse. So our f inverse of x is equal to x to the 3 divided by 3. Okay. And so as far as just finding the inverses, those are all the types of problems that we'll be dealing with. So just kind of recap the types of problems that we could have. The first one was we had y equals 2x minus 1. The next one was 3 over x plus 1. The third one we did was x minus 1 over 2x plus 4. And this last one we just did was the cube root of 3 to the x. So these are like the main type of problems, and how we did each one. So how we did this first one, the steps for that one will always be the same whenever you have something that looks like this. So say a number times x and just plus minus another number. So like the general form of this one, say if you have something like ax plus b. If the problem looks like this, then the steps that we did for this one will always be the same. So the general one for this one, say if you have like a over bx plus c. So some number on the top divided by some number times x plus c. So that's going to be this one. If you ever have a problem that looks like this, you have to do the steps that we did from this problem. So this one right here is kind of like ax plus b over cx plus d. So if the problem looks something like this, you have an ax plus b on the top, and then some other thing with x and another number on the bottom like this. These are the steps that you would use, the one we did for this problem. And for this one, it'll just be n, say ax. If you have the nth root of something times x, we'll do all the steps the same like this. So these are like the four, just I guess, types of problems that you can be asked, and how we did each one is the same for, like the general type of problem. So the last thing from this section that we need to talk about is called the inverse function property. So So what the inverse property, function property says is, so say if we have our function f of x, and just like before, we do all this work, and then we end up finding what f inverse is equal to. So these two things need to satisfy a certain property. And what that needs to be is that if we do the composition of them two, so f composed with f inverse of x, it equals x. This is the inverse function property. Again, so with this, if we remember from, I can't remember chapter, I think chapter 1 or chapter 2, when we found what this was, this means that if we take f and we plug f inverse inside of it, this needs to be x. So this is just the same thing, another way to write that. So in one of the previous examples, let's do from example number 2 that we did. We were given that f of x was equal to 3 over x plus 1. And we found f inverse of x was three over x minus 1. So let's show that these two actually are inverses of each other, meaning they satisfy this property. If we do f composed with f inverse of x, we get x. So this is like the sure way to test to make sure you didn't make a mistake. So say we started with this, we did all the work, we ended up getting this. If these two functions satisfy this property, then they're for sure this one's going to be the inverse, or this one will be the inverse of this one. All right, so let's test to see if this property is right. So we take f, and we want to find this, f composed with f inverse of x. If you remember that just means we're plugging f inverse inside of f. So here's f, we're going to plug f inverse of x inside of it. F is this function. So whenever you plug inside of f, it just goes right here. We're going to have 3 divided by that thing plus 1. So we're plugging f inverse inside of f. So we're just going to put an f inverse here. So this is going to be 3 f inverse of x plus 1. Again, so whatever you plug inside of f, it just goes right here. If you plug in a 4 goes here. You plug in a 0 goes here. Now we're plugging an f inverse in. So if we plug an f inverse in, the f inverse is going to go right here. Okay, so now let's continue simplifying. Well, f inverse of x, we found that to be 3 over x minus 1. So this is going to be 3 divided by, f inverse of x. 3 over x minus 1. Plugged it in, 3 over x minus 1, and we have this plus 1. Okay, so now let's keep simplifying this. And our whole goal is to, if we didn't make a mistake, we need to get this to be equal to x. Okay, so the next step, just the 3 on the top. Let's just not write these parentheses anymore. So 3 over x minus 1 plus 1. Now let's simplify the bottom a little bit. We have a minus 1 and we have a plus 1, so those just go away. So we have 3 over x. Okay, but now what we have is a fraction divided by a fraction. The top is just 3, and the bottom is 3 over x. So if we remember how we divide fractions, we just take the top. In this situation, the top is just 3. And we multiply it by the bottom turned upside down. So instead of multiplying by 3 over x, we're going to multiply by x over 3. But now we see that this 3 and this 3 cancel. So that goes away, and we're just left with x. So this is the property that we needed. What we just showed was right here, f of f inverse of x is equal to x. And that's the same thing as this property up here. So what that shows is that for sure we didn't make a mistake, that this is actually the inverse of this one. Okay. Let's do one more example like that. Let's do it for the third one we did. So the third example we did, we started with f of x is equal to x minus 1 over 2x plus 4. And what we found is that our f inverse of x was equal to minus 1 minus 4x all over 2x minus 1. Okay, and so we want to show we didn't make a mistake using the inverse function property, meaning we want to show this. We hope this is going to be true. Okay, so, not 0, equals x. Okay, so let's do some work with this, simplify, and hopefully we get x. So f composed with f inverse of x. Again, this means we're taking f inverse and we're plugging it inside of f. Okay, so here's f of x. Whatever you plug inside of f, it's going to go here and it's going to go here. Now we're plugging in our F inverse, so the F inverse has to go here and the F inverse has to go here. So the top is going to be F inverse of x minus 1, so F inverse of x minus 1, and the bottom is going to be 2 times F inverse of x plus 4. 2 F inverse of x plus 4. Okay, so we did that. Now the next step is, well, let's just plug in the F inverse of x's. Do that right here. So F inverse of x is this whole thing. Minus 1 minus 4x, 2x minus 1, and we still have this minus 1. On the bottom, we're going to have a 2, F inverse of x, so minus 1 minus 4x, 2x minus 1, and then we have our plus 4. Okay, so now there's just a lot of simplifying we need to do. We'll simplify the top, and then we're going to simplify the bottom, and then combine everything, and at the end we should get x. So on the top, what we can do is, well, let's just first get rid of all these parentheses. We're going to have a minus 1, minus 4x, 2x minus 1, minus 1. And then on the bottom here, we can distribute this 2 through this set of parentheses. So the 2 is going to go to the top of this one, top of that one, so we're going to get minus 2 minus 8x over 2x minus 1. And then there's still a plus 4. Okay, so again, all we here is distributed this 2. So you can also think of this 2 as 2 divided by 1. So really you're multiplying 2 fractions here. And you always multiply the tops and you multiply the bottoms. So we're multiplying 1 by the bottom, we just get 2x minus 1. Multiply 2 by the top, so 2 times minus 1 is minus 2. 2 times minus 8 is minus 8x. And then we still have our plus 4. So now, in order to simplify this, well, we have to combine these two things, this fraction with the minus 1 and this fraction with the plus 4. So we need to get common denominators for both the top and the bottom. So just for the top, here's the bottom is 2x minus 1. So we need to, if we want to combine this with a minus 1, well, we need to have the bottom of this 1 be 2x minus 1. So how we do that is we have 1 minus 4x, 2x minus 1. So we need to put a 2x minus 1 on the top of this and a 2x minus 1 on the bottom. So we're going to turn this 1 into 2x minus 1 over 2x minus 1. Again, so 2x minus 1 over 2x minus 1, that's just equal to 1. You can cancel both of these things out, they're the same thing, and you just get 1. So this top, minus 1. So this top right here is the same thing as this top. All we did is made a common denominator. The bottom is 2x minus 1, so here's the bottom is 2x minus 1, the same thing. Now let's do the same thing on the bottom. So again, we have to put a 2x minus 1 on the bottom of this, of the 4, and also on the top of the 4. So minus 2 minus 8x, 2x minus 1, plus 4. So we got to put a 2x minus 1 on the top and a 2x minus 1 on the bottom. So now we've got common denominators on both the top and the bottom, so we can just combine these things on the top. Let's make this bigger so we can distinguish between the top and the bottom. So just combining the top. These denominators are the same, so we can just combine these tops. We have minus 1 minus 4x minus all of this. So minus 2x minus 1 all over 2x minus 1. All we did is our same denominator, we can combine the top. This thing minus all of this thing. And remember, we have to keep this in parentheses. This minus has to go here, and the minus also has to go to the minus 1. Now on the bottom, same thing, same denominator, so we can just combine these tops. Minus 2 minus 8x plus this whole thing. 4 times 2x minus 1. All divided by 2x minus 1. Okay, so now let's just sort of just ignore this big fraction and just simplify the top and simplify the bottom as much as we can. So here we have minus 1 minus 4x minus 2x minus the negative 1, so plus 1 over 2x minus 1. And here we have minus 2 minus 8x plus 8x minus 4 all over 2x minus 1. Okay, so let's see, things are going to cancel a little bit on the top. Well, here's a minus 1 and a plus 1. Those go away. So all we have is minus 4x minus 2x, which is going to be minus 6x, over 2x minus 1. Okay, so down here, here's a minus 8x and a plus 8x. That goes away. And we have a minus 2 and a minus 4, so a minus 6. And that's divided by 2x minus 1. Okay, so now we're at the, one of the last steps. Here we have a fraction divided by a fraction. So we know that in order to simplify that, we just take our top fraction, minus 6x, 2x minus 1, and multiply it by the bottom fraction where we turn it upside down. 2x minus 1 all over 6. Now several things are going to cancel here. This 2x minus 1 on the bottom cancels with this 2x minus 1 on the top. This 6 on the bottom cancels with this 6 on the top. Well, that was a minus 6, sorry. So this minus 6 on the bottom canceled with this minus 6 on the top. Remember, so we had here minus 6x over 2x minus 1. That's right here. Multiplied by the bottom turned upside down. So the bottom was minus 6 over 2x minus 1. So we put 2x minus 1 over minus 6. So these minus 6's cancel. And the only thing you're left with is this x right here. So equals x. So that's good. We didn't make a mistake. What we found was, so here, f composed with f inverse of x. We did all this work. And we showed this, f composed with f inverse of x is equal to x. So that's good. That means that this is actually the inverse of that. So this one was really messy, but luckily we didn't make a mistake. And at the very end, we get this thing is equal to x. Okay, so the last thing from this section. This is sort of just like a domain and range property. F of x and f inverse of x. So there's a relation between the domain and range of these two functions. So they are is that we have the domain of f of x. That is the same thing as the range of f inverse of x. And the range of f of x, that's the same thing as the domain of f inverse of x. So let's do so why is this helpful? So I mean, sometimes there'll be a question that says find the range of f inverse of x. Let's just do it with a previous example we just did. So we saw that f of x was x minus 1, 2x plus 4. We did a bunch of work and we got f of inverse of x was equal to negative 1 minus 4x over 2x minus 1. This was the third example that we did. And we verified this in the previous example we just did. So when we did this, we did all the work, we got that. So say if a problem said, let's do, find the range of f inverse of x. So it's very hard in general to find the range of a function. When we found the domain of a function, it was easy. There was always those steps. You either look for square roots and fractions, you set the bottom of a fraction equal to 0 or the inside of a square root bigger than or equal to 0, and you do all those steps and then you find the domain. So there's always a sequence of steps to find the domain, but that is not the true for the range. So in this problem, when it says find the range of f inverse of x, so find the range of this, in general, that's not really possible to do without like a computer or like more advanced techniques. But we can use this relation up here. We know the range of f inverse of x, that's the same thing as domain of f of x. And we can find the domain of f of x. To find the domain of this is pretty easy. So instead of finding the range of f of it, this is what the problem wants us to do. Find the range of f inverse of x. But instead of doing that, what we're going to do is find the domain of f of x. Again, because we can use this relation up here. The range of f inverse of x, that's the same thing as the domain of f of x. So instead of finding the range of f inverse of x, we'll just find the domain of f of x. And those two things are going to be the same thing. So find the domain of f of x, let's just rewrite that. X minus 1 over 2x plus 4. Okay, so remember when we're finding domain, there's two things. We look for fractions and then square roots. In this problem, we don't see any square roots, so nothing to worry about with that one. But with fractions, this whole thing's a fraction. Yeah, so we see fractions. And whenever we see fractions, the bottom of a fraction can't be 0. So what's the bottom of this fraction? It's going to be 2x plus 4. That's the bottom of this thing. So 2x plus 4 can't equal 0. So if we subtract the 4 over, it means 2x can't equal minus 4. And if we divide by the 2, this means x cannot equal minus 4 over 2, so minus 2. So just like always, you go to the number line. Here's minus 2. We can't be that, so we're going to put a circle on there. But nothing else was an issue. Again, we saw there's no square roots. There's no issue that we can have with square roots, so we don't have to worry about that. And the only issue with the fraction is when the bottom is 0. And the only time that's going to be is when x is going to be minus 2. So x can't be minus 2. Because when x is minus 2, the bottom of this is 0. But that's the only issue. So all these numbers to the right, those don't cause a problem. All these numbers to the left, those don't cause a problem. So the domain of f of x is going to be minus infinity up to minus 2, union minus 2 to infinity. But again, we said a second ago, we wanted to find the range of f inverse of x. What we just did was found the domain of f of x, which is the same thing, because we said we can't find the range of f inverse. It's too hard to do. But we can easily find the domain of f of x, and those are the same thing. So this right here being the domain of f of x, well, this is also the range of f of x. So this is, let's write that, the domain of f of x, and also the range of f inverse of x. So this is going to be our answer. And so we're not going to do this, but say if the problem said find the range of f of x, what we'd want to do is find the domain of f inverse of x. So if we wanted to find the range of f of x, instead what we would do, which would be much easier, is just take this function and find the domain of it by just doing the same techniques we just did. Okay, so that's going to be all we have for section 5.1.